Hello everyone and welcome back. In this video I'm gonna go over the timer for the Atari 2600, so stick around for that. Alright, so let's get started. In here with our Stella Programmer Guide manual. And we're gonna cover our PIA, which is a peripheral interface adapter, since I already covered most of the graphics part of your Atari 2600. And as it says over here, it has three major functions. Our programming timer, the topic of this video. We have a RAM, which you've been using for a while now. Let me if I assemble this. Here's a RAM from 80 to FF. That should be self-explanatory at this point. And we also have our parallel ports over here, your input and outputs for your controllers and so forth. But let's go back. Let's go cover our timer interval. And if you notice, let's go right over here. We have from the value 1 to 255, and if you notice, that's the exact same values, the max values that an 8-bit or 1 byte address has right over here, because that's the maximum value that we can store on a 1 byte storage, like the 6507 that we have over here. And it's called, you have a clock interval over here, because you're gonna give a value to these registers over here, and these values and this registers at this specific address is gonna decrement our value that we store over here by this interval amount. So if I put the amount 255 for every 1 clock of the 6507, it's gonna decrement by 1. So one clock has gone by, 254, another clock 253, and so forth. But there's gonna be times where we're gonna need a bit more time than 255, because if you come over here, what happens when you reach 0? It's pretty much gonna overflow. And it says right here is a feature, so to allow us how long the clock has passed since it reached 0. So here we have our 1 clock interval, and like that's gonna be a lot of times, we're gonna need more than 1. So they also give us a few more clocks that to work with, and each clock has different intervals. For here you have 1 by 1, here you have 8 by 1. So for every 8 TA cycle, for 8 TA, my bad, for 8 6507 cycles, is gonna be increased by one timer for this timer AT. Meaning we go from one value from 0, 1, 2, 3, 4, 5, 6, 7, 8. Then this timer 1T is gonna decrement this value by 1, and so forth. So 1, 2, 3, 4, 5, 6, 7, 8, another 8, then this value that's stored on this register is going to be decremented by 1. So that's the exact same thing with the 64 clocks and the 1024 clocks. So for every clock cycle of the 6507, it's going to get decremented by 1. So let's just get to the code and show how that works. So let's get to this part over here. Instead of doing this repeat and repeat end, let's use a timer. And let's so to start it off, let's go to your Spiceware blog, which is cover timers, and here it has how it works. And here is our equation that we're gonna use in order to use our timer correctly, at least how we need it. And here you have scan lines, which is the number of scan line times 76. Since, let me go open this picture over here. Oh, not you, right here. If you notice, the whole vertical line that we have here from horizontal blinking all the way to the end of the display screen, the whole thing takes 76 machine cycles. So if you're pretty much doing a, let me open it back. Let me open my calculator. So if you're using the timer 1t, it's pretty much you're gonna use our amount of scan lines. For example, if I want 35, that's oops, times 76. Oh, not 35. So if I want 35, oh, not 35, 35 scan lines, I just put 35, and after 35 machines, 6502 cycles, it will decrement to 60. So if I wanted one scan line, that's just 76 of the 1t. And if I want two scan lines, it's just 76 plus 76, so we get 2, and so forth. So if so 2 scan lines, so you're gonna 2 times 76, and so forth. If I want another 76, that's fine. But as soon as I add another one for 4, it goes over the value that we need. It's a bit too big. So here, for example, if you need a bigger one, some bigger values, you divide it by that value. So meaning if I want, let's say 37 times 76, 37 because this is 37 times 76. That's the value. If you're divided by 8, if you want the timer 8t, right over here, then it's still too big. That's why you have a higher values of or higher interval times here. But we're not gonna cover this 37. We actually want 192. So let's do the math. Times 76. Then divide it by 60. Then I'm gonna divide that by 64. 228. And that worked out. That's even out. A lot of the cases not gonna be. So let's do this 37, for example, times 76 divided by 64, and here you have, it's not exact an even number, so you're gonna have to round it up or down. So was it 128? 76, 228. Okay, so let's do that. So let's go to the code, like I said. So we're gonna load y that value and store that into our timer, and it's gonna decrement for every 64 ticks over registers over here. Make a label. You're gonna store that, then you're gonna load whatever register we wait for register over here, so it's being decremented by each interval, and then we're gonna branch y is not equal 0 to here. So that's pretty much it. And let's assemble. It should be working perfectly. And just to demonstrate that it works, let's let me just copy this and paste over here. And copy this and paste over here. And right over here, let's change this to 64, something like that. So let me bring the picture over here. So this vertical blank should be the red color you've seen forever. This should be black. And this would be a different color. Let's assemble. And here it is, working how the timer should be working. So that's pretty much how timer works. So you can always change your values over here. Just follow the equation that you had over there. And one question you're gonna ask why you should be using a timer instead of this repeat or whatever specific thing we have over here. And that's simply because sometimes we don't know how long something's gonna take. For example, if I had a controller, if I press the action button or the big red button on your controller, and it does something like shooting, does some calculations, and if you branch, you don't know how long, you know how long that's gonna take, but you don't know if the player is gonna press that button. So if you press that button and it takes 2 scan lines to do work, and he doesn't press that button, you meaning that you pretty much like choose scan lines before, choose scan lines under or over, whatever the case is, on our code over here. So to fix that, I can always use a timer, work with that, and then do our calculations and stay compact, so you know how much time you have on our scan line is going. Otherwise, there's gonna be times where you're not sure and you're gonna need a timer to work with instead of putting our specifically telling us to start on the line and so forth. So we're gonna see once it's gonna be needed. So with all that said, that's it for this video. In the next video, we're gonna cover the rest of the PIA, which is our 2 8-bit parallel ports. And with all that said, thanks for watching. See you guys.